Alrighty, what about the second law of motion? F equals ma. For each scenario, the forces acting on the body cause it to accelerate. This means that the resultant forces are unequal. Let me explain. Here, we have a resultant force P, right? And we know that it's going up, which means that this P has to be larger than this 2G. Which means that if we're resolving up, right, P minus 2G is equal to mass times acceleration, which is equal to 2 times 6. No, 2 times 3, because our acceleration is 3. This means that we can solve it like an equation to work out what the forces are, okay? This means that P minus 2G is equal to 6, and therefore P is equal to 6 plus 2G, which is equal to 25.6 newtons. Keep in mind that G is equal to 9.8 meters per second squared, okay? Now, let's look at the second example. For the second example, we have two forces going down. We know that it's accelerating downwards, and we have a P resistive force going upwards. This means that if we resolve downwards this time, we know that 4G plus 10, that's everything going down. We have to subtract it by everything going up, which is P. And that's equal to MA, which is equal to 4 times 2. Okay? This means we can now solve it like an equation. So, P is just going to be 4G plus 10 minus 8, because we're just going to put this on the other side and this on the other side. And if all goes to plan, we should get an answer of 41.2 newtons. Okay? And that is your final answer. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at this one. An astronaut weighs 735 newtons on Earth and 120 newtons on the moon. So work out his acceleration due to gravity on the moon. Well, we know that on Earth, G is equal to 9.8, which means that the weight force F is equal to his mass times acceleration, which means 735 is equal to mass times 9.81. I'm just actually, for the sake of purposes, we're going to use 9.8. Okay? And so therefore M is equal to 735 over 9.8, meaning that his mass is equal to 75 kilograms. Okay? Now, how fast does he accelerate on the moon? Well, his force is equal to his mass times acceleration, which means that his acceleration due to gravity is going to be his force over his mass, which is 120 over 75. 120, excuse me, over 75 is equal to 1.6 meters per second squared. That is his acceleration due to gravity on the moon. Is this still not making any sense to you? Well, you can join my Discord server and ask me any questions you want. Now let's look at this one. A force of 10 newtons acts on a particle of mass 3 kilograms, causing it to accelerate 2 meters per second along a rough horizontal plane. calculate the force due to friction. Now, for this example, we want to use a diagram. This is my diagram, okay? We know that the force is 10 on this side. Sorry, not in meters per second. This is newtons, okay? We know that the acceleration is 2 meters per second squared, right? And we know the mass is 3 kilograms, which means that there is a resistive force R due to friction. We're solving it the exact same way as we would normally. 10, if we were, resolving it to the right, excuse me. 10 minus R is equal to the mass times acceleration, which means that R is equal to 10 minus 6, okay? All we're doing is we're putting this on one side and this on the other side, giving us an answer of 4 newtons of resistive forces. Thank you guys for watching. Do you guys want to get tutored by me and pass your exams? Well, drop me an email and we can organize a meeting. Keep on learning, as you have no idea what you're capable of doing.